All right, this video we're going to tackle 3 problems, and your homework and your video problems will look just like these 3 problems. So first thing we're going to do is label our triangle, and we know that this is going to be an x for our hypotenuse. We also know that we're going to have a 2 for a leg, and the other leg is going to be an x squared, or a square root of x squared minus 4. So what we are aiming to do is get a match with the square root, the dx, and the x. And let's start with the x and the dx first. So let's go ahead and create an equation with the x and the 2. We always want to choose the x and the number, the constant. And so I can certainly try to do cosine here. Adjacent over hypotenuse is 2 over x. But you'll see that with this situation here, it's really not good because we'd have to do product rule right here, and it's going to be really messy. So unfortunately on this problem, you can start that way and say, shoot, that's not really giving me an easy x. So what I'm going to do next is I'm going to try secant. So secant is the reciprocal of cosine. So that's going to be hypotenuse over adjacent, in this case x over 2. Here I'm going to times 2, okay, and that's going to give me 2 secant theta is equal to just plain old x. And do you see how that is just so much simpler in terms of solving for x? So I'm going to box that because we actually have a match with our x right here. Now I'm going to take the derivative, and the derivative of 2 secant theta is 2 secant theta tan theta. And then don't forget your d theta, because you took the derivative with respect to theta. And then the derivative of x is 1, and then we'd have a dx. And certainly we don't need that 1. So now I have another match, which is pretty exciting. So there's my dx. Now, last thing I want to set up is a trig expression with these 2 things. And the hint is you're either going to use that or that, most likely, something so that we'll have a cancel later on. In this case, clearly we have tangent of theta is opposite over adjacent. In this case, 2 over, just kidding, square root of x squared minus 4 in the square root, and then over 2. See how that's opposite over adjacent? There we go. All we have to do here is multiply by 2, and I get 2 tan theta is equal to the square root of x squared minus 4. If you're not sure what I did here, I just multiplied by 2, and then those cancel. All right, I'm going to go ahead and box that here too because I have a match. So now I'm going to go ahead and plug into my integral with the substitution. This right here is going to be replaced with a 2 tan theta, and then divided by my x is going to be replaced with a 2 secant theta. Now my dx is going to be replaced with a 2 secant theta tan theta d theta. Now this is pretty exciting because we have the secants canceling. We also have this 2 canceling with this 2, and we are left with, I'm going to pull this 2 out, a 2 times tangent squared theta d theta. And now this is something that I would give you this. The integral of tangent squared is going to be tan theta minus theta, and then don't forget to put your 2 back into the equation. So now going ahead and I'm going to distribute, I'm going to get a 2 tan theta minus 2 theta plus c. And we're not done, folks, because we have an integral in terms of x, which means that our answer should be in terms of x. So we have a nice match right here. 2 tan theta is this. But then I have to solve for theta in this case. And I'm going to go back to, I don't know, we'll go back to this one right here. Originally, I wrote that tangent theta is that over 2. So clearly theta is equal to tan inverse of the square root of x squared minus 4 over 2. So I'm going to plug that back in here. So I'm going to have a minus, then I'm going to have a 2, and then I'm going to have in parentheses tan inverse the square root x squared minus 4 over 2. All right, so kind of a cool problem. And you might have also said to yourself, could I have put something else in for theta? And you certainly could have taken this original here and you could have solved for theta as theta equals secant inverse of x over 2. So you could have also had this in for this right here. All right, next problem here. Now, first thing we have to do is we have to draw our triangle correctly, and not going to spend much time on that. We should be an expert on it, but I'm going to have this. And so we have to get our matches. So let's go ahead and start with our x, and I'm going to get x is equal to, or excuse me, I need to use this and this. So this is going to be tangent of theta equals opposite over adjacent. So that's going to be 2x over 1. So then I get tangent of theta. I can actually multiply by 2 over 1 here. Actually 1 over 2. Thanks for your patience. So my 2 is going to cancel with my 2, my 1 is going to cancel with my 1, and I get a 1/2 tan theta is equal to x. All right, taking that derivative, I'm going to take the derivative and get 1/2. That's going to give me secant squared theta, d theta, equals dx. And I'm pretty happy I've got my first match. Woo, I'm happy. All right, next thing I'm going to do is I'm going to solve for the square root of 4x squared plus 1. So that there is going to be secant theta is going to be equal to hypotenuse over adjacent, or you can see that that's just going to be equal to just that. So I already have my match. And if some of you were like, hey, how'd you choose secant? Well, this was a pretty darn big hint right there. All right, now let's go ahead and put into our integral. We're going to have 1 over, here's my match down here. That's going to be a secant theta. And my dx, my match is right here. And that's going to be a 1/2 secant squared theta d theta. All right, so what I can do is pull this 1/2 out. So that's going to give me a 1/2, the integral of 1 over secant theta. And then you can think of a secant squared theta as secant theta times secant theta. And we know that this will cancel. So we're left with the integral of 1/2 out in front, and then we just have a secant theta d theta. And this is going to be equal to, and this is something, folks, I'd give you, so don't panic. This will be 1/2, of course, and then the natural log of secant theta plus tan theta. Plus c. Again, I would give you that the integral of secant is this, but you'd have to remember to put in the 1/2 from outside here. All right, now we need to go ahead and substitute back in. So our answer is going to be 1/2 ln. What is secant theta? Well, I have that right here. It is the square root of 4x squared plus 1. And what is tan theta? Well, let's just go right back to our original up here. We had that tan theta equals 2x over 1. Well, that means we've got just 2x. Because 2x over 1 is 2x. And then we could just go plus c. All right, one more problem, and then we're done with videos on trig substitution. All right, so let's go ahead and draw this triangle for this problem. We've got an x here, a 1 here, a square root of x squared plus 1. So first thing is, let's go ahead and solve for x so we can get both an x and a dx. So I'm going to put my theta here. I kind of did a reverse triangle here. That's cool. That's going to be opposite and adjacent. So that's going to be tangent of theta equals x over 1. Well, we know that x over 1 is just x. So there's a match already, tan theta equals x. And then let's take the derivative. That's going to give us a secant squared theta d theta equals dx. And again, I've got a match. So now I need to solve for square root of x squared plus 1, and that is going to be secant. And here's the big hint. If you see secant, you're probably going to use it here. So secant of theta is hypotenuse over 1, which is really nice. That just disappears, that over 1. So we've got our matches already. So this is going to be the integral of x, which in this case is tan theta. And then it's going to be divided by square root of x squared plus 1, which is a secant theta. That came from right here. And then my dx is a secant squared theta, which I'm going to write as secant theta times secant theta, and then I've got my d theta. So here I've got my secant theta and my secant theta canceling. So I'm left with the integral of tan theta secant theta. And this one you should know by heart. This is just going to be secant because the derivative of secant is tan times secant. So our answer is secant theta plus c. And we're really lucky because we have already solved for secant, which is the square root of x squared plus 1 and then plus c. And we are done. Thanks for doing 3 problems with me. Bye now.